Okay, so which congruent statement does not necessarily describe the triangle shown if DEF is congruent to FGH? It says not necessarily describe because it's possible if, for example, we had isosceles triangles here that you could reverse the positions of the vertices and it might still be congruent that way. So they say just not necessarily because there are some ways where we definitely know that it will be congruent. And if we take a look at it, we're looking at, you say triangle DEF is congruent to triangle FGH. I'm going to mark them with angle marks. So D corresponds with F. E, the middle letter in both of the names, corresponds with G. And F corresponds with H. 3 marks. Okay, so then what we're looking at is to see that the vertices match up correctly. So here we've got the first one. E matches with G, that's true. D matches with F, that's true. And F matches with H. So that one works. Let's check B. F matches with F. Ah, that's not true. F does not match with F. D matches with G. Nope. E matches with H. Nope. So we're looking at B as the one that does not necessarily fit. Let's check the rest of them though. E matches with G. E matches with G. There's E and G in the middle. F matches with H. F with H. Yep, the 3 marked one. F with H. D with F. Good. FED and HGF. F matches with H, F matches with H, yep. E matches with G, that's true. And D matches with F, also true. So we are correct that the one that we are looking to identify as the one that's doesn't, the way that we understand it and the way we're told up here on the top with the congruent statement, B does not fit that and agree with that. So that's one we're trying to identify. So we're done.